For questions 1 and questions 2, it's all about knowing these definitions. So you can read about these definitions in the textbook, watch the webinars. The Help Me Solve This really explains the definitions. So one of them is qualitative versus quantitative. Qualitative, think qualities, non-numbers, non-numerical, whereas quantitative, think quantities, numerical values. And for dependent or independent samples, for independent, think free. They're not really tied to each other, so the samples can be different sizes. The data in one sample doesn't dictate what's in the other sample, whereas with dependent sampling, both samples have to be the same size, and what goes in one sample directly dictates what goes in the other sample. So for number 3, we're going to start with hypothesis testing for 2 separate populations. And our assumption is always that the 2 populations have equal proportions. And we're going to use our hypothesis test to check to see if that's true or not. And here it tells us that our alternative is going to be that the proportion from population 1 is greater than population 2. And so we're going to gather samples and run a hypothesis test to see if that's true or not. And I'm going to show how to do that with StatCrunch. So here in StatCrunch, I want to go to Stat. And we're looking at proportion stats. And we have 2 samples. And we have the summary data. I forgot to click on that there, the summary data. And so our first sample has 125 successes out of 255 total observations. And then enter the data for the second sample as well. And we don't have any background information here. We just have the numbers. And then we're going to do our hypothesis test. And so it's phrased a little bit different than what we see here in the problem. But just use the algebra here. And we want to do a greater than. And you would see it's exactly the same. If you added P2 to both sides, you'd have P1 is greater than P2. Or if you subtract P2 from both sides, you have P1 minus P2 is greater than 0. So that is matching the hypothesis that we want. And we're going to hit compute. And we get all of our information back here. And get down here so we can scroll over and you'll see our z-test statistic and our p-value. And just like with previous hypothesis testing, if the p-value is smaller than our significance level, we will reject the null. But since this value is larger than our alpha, we do not reject the null hypothesis. For number 4, we are again dealing with 2 separate populations, and we're comparing the proportions from those 2 populations. And we're going to be building a confidence interval for the difference in those proportions. So StatCrunch is again going to be a great tool for us here. We want to go to proportion stats. We have 2 samples, and we have the summary data. So we enter in our information from both of our samples. And in this case, we're looking for a 90% confidence interval. So I'm going to scroll down to confidence interval and put in 90%. And when I hit compute, you're going to get the lower and the upper bound. If we can scroll over here, we get our lower limit and our upper limit. For question 5, we have some information behind our numbers. Now, we have way back in 1950, a sample of adults asking if they're complete total abstainers from alcohol. And then we have a recent survey that asks the same thing. So we're comparing the population of people in 1950 to the population of people today. And we really just want to see if there's been a change in the people and the proportion of people who say they're total abstainers from alcohol. And so that's going to define our null and our alternative. Our null is always that those 2 proportions are going to be equal to each other. There's been no change between 1950 and recently. And then our alternative here is that there is some change. We don't know if it's gone up or down, but we're just looking to see if anything's changed. And so before we actually conduct this hypothesis test, let's scroll up here and actually do the beginning parts of the problem now that I've set it up. So one thing we just want to do is look at the sample proportions for each sample. And so you're going to take the number of successes in the sample and divide by the size of the sample. So back in 1950, we had 429 out of 1,100. So you had that proportion from 1950. And then in my example here, our present day is 385 out of 1,100. And so you get a different proportion. So the proportions are different from our two samples, and that's to be expected. It'd be very rare if they're exactly the same between different samples. But is this difference enough for us to reject the null hypothesis and conclude that the alternative is true? So that's what the hypothesis test is going to tell us. And it tells us the level of significance we are going to use. And now we're going to verify that we can actually do a hypothesis test. And so in part B, we are going to select all of these that apply. The sample size here is only 1,100. So that's not more than 5% of the human population. So we would select this one, though the sample size is less than 5%. Now these samples, people in 1950 to the recent people, there's no relationship between who was selected. So we don't have dependent samples. Instead, we have independent samples. We're not told anything about it being normally distributed, so we don't want to select that. And then you can verify this. If you take the sample size times these proportions that you already figured out here, and then 1 minus that proportion, you'll see that both of them are larger than 10. And so now we can move forward with the hypothesis test that we set up, and we're going to use StatCrunch to get these values. So in StatCrunch, with the two sample proportions, summary data, enter in what you have for each sample. Make sure you have the right hypothesis test set up for your null and alternative. And then you'll be able to scroll over and get your test statistic and your p-value. And this p-value is larger than what our alpha was at 0.01. So we will not have enough evidence to reject the null hypothesis because alpha was only 0.01. And so that is the last part here. We're not rejecting the null hypothesis at this level of significance because our p-value was higher than that. There's not enough evidence to conclude that there's been a change in the proportion of adults who totally abstain from alcohol. And going just a little bit before that, we needed to interpret the p-value. And so we always assume that the null is true, which is stating our null was that the two proportions are equal. So under that assumption, the p-value tells us the probability of getting samples like the ones we did, or ones that are even further into the tails of the distribution, which means the sample proportions are even further apart, or that they have a greater absolute value in their difference. So that's what the p-value is telling us, the probability of getting samples like the ones we did or ones that are even further spread apart, greater in absolute value. And our p-value was right around 5%, and 5% is 5 out of 100. So if we repeated this 100 times, we'd expect results like we got, or even more extreme, 5 out of 100 times.